Great, thank you very much, and thanks for the flexibility and patience with shifting the schedule around. We've recently changed our file permissions, and it seems like we've made it so secure that I can't share my slides. But I'm actually a bit glad about the change of schedule because the previous speaker talked about the Elundu et al. AI exposure, and our work is very related to that paper. You can think of our work as like Elundu et al. Used humans and LLMs to rate tasks based on how well they thought AI could perform that particular work task. And what we're doing is looking at consumer LLM usage and seeing, based on how people are actually using LLMs, what do we think occupational exposure is. So this is work that I've done at Microsoft with some great colleagues, Sonia, Will, Scott, and Sid. So I'll go a bit quickly over this slide. I'm sure I don't need to motivate too much how LLMs are changing work and how they're being adopted at a massive rate, and their capabilities are increasing exponentially. So it's super important to understand how these growing capabilities and this massive adoption rate will change the way that work is done. And given that we have very rich data about how people use an LLM at large scale, our goal was to use logs from Microsoft Copilot to identify how people were using LLMs to perform different work activities, and what those conversations indicated about which work activities were being performed more or less successfully. And our goal was to, by identifying this applicability of LLMs to work activities, then be able to understand how it might change the way that different occupations do their work. So to answer this question, we looked at a random sample of Bing Copilot logs from the first 3 quarters of 2024. We got 100,000 conversations sampled randomly from US conversations over this period, and an additional 100,000 that had thumbs up or thumbs down feedback from users. So we can see which conversations people think are more or less successful. To understand work, we use the ONET database, which contains a collection of occupations performed in the US, as well as tasks that are done in those occupations. To give you a little bit more of a sense of ONET, one occupation in ONET is my job, computer and information research scientist. There are about 1,000 different occupations, each of which is mapped to, on average, 18 tasks. These are job-specific descriptions of a unit of work done in that job. Then these tasks are mapped to work activities that apply across occupations. There are fewer of those. For example, analyze data to identify trends is one detailed work activity in ONET, and these are then clustered into intermediate work activities, or IWAs, which are the level at which we did our analysis. So one work activity that I do is analyzing scientific or applied data. So what we do is we map Copilot conversations to IWAs and then evaluate the demonstrated capability of the AI in that conversation to assist with or to perform that work activity. Let me give you an example of a conversation. So let's say a user pastes in a command line error message, and the LLM replies with instructions for updating the configuration of their software. One of the things that we noticed early on is that it's very common for the goal of the user and the action the AI takes to be complementary but different. So the user's goal is to resolve some issue with their software. And in this conversation, the AI plays the role of an advisor. It tells them how they can update their configuration. So when we map these goals to work activities, we might say that the user is trying to resolve a computer problem, which is an ONET work activity, whereas the AI is trying to advise others on the use of technologies or explain technical details of products or services. And this reflects how LLMs can be applicable to work in multiple ways. On the one hand, they can help a user accomplish the goal that they set out to do. And the types of jobs that do resolve computer problems are things like programmers, system administrators, etc. Or LLMs can stand in for a third party, some other assistance that the user might otherwise have sought out. So for example, here the AI is playing the role of an IT technician or a tech support worker. So we classify the work activities in a conversation into these 2 separate sides. So on the one hand, we identify all work activities that correspond to the user's goal and to the AI action. For every matched work activity, we also evaluate the impact that the AI's capability demonstrates in that conversation towards that work activity. So in some cases, this might be a rather narrow contribution towards assisting with resolving computer problems. But in other cases, when the work activity aligns very closely with the capability the LLM is demonstrating, like for edit documents, then we might say that there's a much broader scope of impact on that work activity. So we score these using an LLM classification, and in addition, classify for every conversation whether the AI successfully completed the user's goal. We call this completion. So let me now turn to our results. I'll talk about what work activities people used Copilot for, which ones were most successful, what this means about occupations, and how this compares to Elandu et al. AI exposure, as well as talk briefly about some socioeconomic correlates. So what did people use Copilot for? The most frequent user goals that we found involved learning, gathering information, maintaining knowledge, reading documents or materials, as well as writing was very common. There are IWAs like edit written materials or documents, as well as some teaching, explaining, and communicating work activities. Some that kind of weren't in these top 10 or 15 that I'm showing here included things like data analysis and image generation. On the other hand, when we look at the action that the AI is taking in the conversation, we see that it's dominated by these communication and teaching and explaining work activities. So in general, with this consumer-facing LLM, people were trying to learn and write, and the LLM was kind of explaining and advising and providing assistance. And one of the things that surprised us was that the work activities that we mapped on the two sides ended up being very different. In almost all conversations, there were more work activities unique to each side than there were in common. So there really is an important asymmetry here to pay attention to. Okay, so that's what people were doing. What was most successful? To measure success, we used both the user signal of thumbs up, thumbs down feedback, as well as the two LLM classifiers that I mentioned in terms of completion and scope of impact. One of the things that we found is that when we aggregate these signals at the level of work activities, that thumbs feedback ended up being highly correlated with our completion classifier. So this sort of validated that our task completion LLM classifier was picking up some real signal. And another thing we were concerned about is that only a very small fraction of conversations actually have thumbs feedback. So we might be worried that there's a lot of bias in the type of users who provide feedback or the types of activities for which they provide feedback. And so we ended up using just the LLM classifications in the applicability score I'll talk about in a second. But this validation with thumbs feedback we found encouraging. So since thumbs feedback is the most direct and maybe the clearest sense of what people were happy with, let me show you the top and bottom work activities by the feedback positive fraction. So this is, of all the times a work activity was thumbsed, either up or down, what fraction of that was up? So 50% is equal thumbs up, thumbs down, 100% is only thumbs up. What we found is that the most successful work activities involved those things that users do a lot of: research, interpretation of information, evaluation, like evaluating the characteristics of products or technologies, as well as writing, editing written materials, writing material. On the other hand, the work activities that we found were least successful, I'll note that this is filtered for ones that appear at least a certain amount. So of the frequent enough work activities that we found less successful were data analysis and image generation. Although even the least successful ones have a 50-50 thumbs up, thumbs down ratio. We found similar patterns when we look at completion and scope, but I'll skip those for the sake of time. So, okay, now that we know what people are doing with AI and how successful they're finding it, what does this mean about which occupations have the highest AI applicability? To measure this, we compute an AI applicability score by summing over all the work activities that an occupation does from ONET using ratings to determine how important that work activity is to a job. measuring whether there's non-trivial AI usage for that work activity. So are people using AI at all for this? And then if they are using AI at all for that work activity, how successful is it in terms of completion and in terms of scope of impact? So we then end up with a single number per occupation. What we find is that AI applicability was highest for knowledge work occupations. This is perhaps in line with everyone's expectations. Here I'm showing the distribution of AI applicability scores over major groups in the standard occupational classification. And I've highlighted major groups that are kind of traditionally considered to be knowledge work. So the groups with the highest AI applicability were sales, computer and mathematical occupations, office and admin support. And then at the low end, we have a lot of manual occupations like farming, fishing, and forestry, healthcare support, construction and extraction, etc. We can then look at why different occupations were given high AI applicability scores based on which work activities are contributing the most. So this is showing the top occupations by AI applicability score. They include things like customer service, sales, writing, clerks, programmers. And the work activities that contribute most to that applicability, a lot of them are about providing information, writing, explaining, and maintaining knowledge. So, for example, in terms of high AI applicability to customer service, this is because AI is very good at providing information. So this contributes to high AI applicability for customer service representatives, for example. This also highlights a limitation of our approach. You might notice that passenger attendants and hosts and hostesses are there. Those are roles that provide information to customers, but the way in which they provide information and the way in which the AI provides information are very different. And so this doesn't mean that, that all of the instances of this work activity can be done by AI. Just that AI is useful for types of work that are like things done in those occupations. So an asterisk there. Highlighting another work activity about editing written materials, we see a lot of writing occupations, writers and authors, editors, proofreaders. One kind of additional caveat that I want to give is that this, especially this list of occupations, generated a bit of a stir, and unfortunately in a way that really didn't align with the findings from the paper. So, for example, there was this article from the Washington Post discussing whether we thought historians were going to be replaced by AI. And the answer is very much no. So these, our numbers do not say that AI can do these jobs. There's like no evidence in our paper that AI is capable of doing the job of a passenger attendant, for example. This is just about whether an occupation has tasks where AI may be helpful for. And in fact, all of our data is from people using AI as an assistant. So there's, I definitely want to kind of disavow this type of conclusion. And if you want to take a look at the full list of occupations, you can take a look at the paper, and we've also recently made all of the AI applicability scores public, as well as all of our work activity level data. So briefly, how does this compare to how people thought AI might be relevant to occupations? So this is like the Alundu et al. AI exposure kind of predictive measure. Turns out that at the occupation level, and even more so at the occupation group level, our applicability score is quite highly correlated with previous measures of AI exposure. And some of the differences are highlighted by kind of weaknesses of one or the other approach. So for example, here we have high AI applicability for passenger attendants, but the Alundu et al. AI exposure was 0. And in fact, that might be a case where the way in which the work activity is done in the occupation differs from the way people use AI for it. But in general, the story is very similar. We see high applicability for knowledge work occupations and ones involving a lot of communication. And then very briefly, how does this correlate with different socioeconomic measures? So we looked at how AI applicability score varied by occupations with different education requirements and with different average and and median wages. And we found that after weighting by employment, that the relationship was fairly weak. So there is a significantly higher applicability for occupations with a bachelor's than with lower educational requirements. And there might be some kind of trend around the middle of the wage spectrum, but variance is very high. And so we expect to see kind of AI having effects across the education and wage distribution. So to conclude, we find that AI is most applicable to knowledge work and communication, but that there is applicability across the board. Thank you very much. Yes.
Yeah, thank you very much. Maybe I missed it, but can you explain how you map user goals and AI activities to IWAs?
Yes, so we used an LLM classifier. It was a kind of multi-stage pipeline that involved first retrieving work activities most similar to an AI-generated summary of the user's goal, and then doing a binary LLM classification over each work activity, saying, kind of using chain of thought, describe what this work activity means in the context of ONET, describe what the user is trying to do in this conversation. Does this work activity match the goal the user has? On the user side and on the AI side, same thing, but for what the AI is doing in the conversation. Does this work activity describe the action the AI is performing?
You're using Gen AI to match those. And
yes, we are.
Looks like similarity.
Yep, we're using an LLM classifier. We also did human annotation and have validation numbers in the paper. Yes, question here.
So very quickly, was there a systematic process for selecting all these set of things that AI does? So in other words, did you talk to someone in organizations and said, these are the most commonly used work processes? Is there a systematic process?
Right, so maybe there are two parts to that question. One of them is that the set of tasks that people do, we didn't generate. That's purely from the ONET database. So that's like self-reported people saying, what do they do in their jobs? Then clustered by analysts into work activities. The second part is, how do we know what people are using AI for? That's where we just looked at conversation data from Bing Copilot to say, does this match this work activity in ONET? Yes?
Following on that, the crux of the analysis, if I got it right, was essentially to multiply the ONET data and then overlay the evidence that you had in the multiplication. What some of us are getting a little concerned with is the uncritical reliance on ONET that has populated the field and has become a substitute for common sense. Actually turn it on its head and then try to say, hang on a minute, this is a really rudimentarily driven analysis, which for some bizarre reason the entire field is taking on as truth, and start debunking it a little bit?
That is a great question. I very much like it. Yeah, one of the things that I found when working with ONET is that a lot of it doesn't make sense. For example, if you look at what work activities does a software developer do, program computers is not one of them. So there are a ton of issues with ONET. I 100% agree. And
most published papers are on rather rubbish data, and we continue propagating it. So I think that it is time for us to stop using ONET the way that we are as a community. Sorry for pet peeve.
I would love a better alternative. Like
you could start unpicking it because you have microdata, and then you can say, well, what does ONET say? How does that map onto the actual use patterns? And let me at least have an empirical validation rather than something that someone wasn't thinking carefully about the problem did a long time ago, and then we couldn't find anything better, and then we got stuck with something that doesn't make sense, and we reported to the Wall Street Journal as if it's truth. And certainly McKinsey is happy to serve it and amplify it with its comms channel.
Yeah, great question. Maybe I'll go back to my team and see if we can make a better ONET from real data. Yes?
Grace, this might divert from the purpose of the research, but were there any insights or findings to where, when you were looking at the data, there was actually an expansion or a transformation of the actual work task in which the user was utilizing GenAI for, where GenAI helped augment in that way kind of the transformation of the task in which they were doing?
Yeah, so we didn't try to measure the way in which AI might change the task the user is trying to do. That's a really great question and ties in a little bit to some of the next steps that we're hoping to take. So we use just consumer-facing LLM data. We're hoping to, in a eyes-off, privacy-preserving way, also look at enterprise LLM usage. And there we know the job that someone has. We know, okay, through the very imperfect lens of ONET, what tasks they might have in their job. And then we can see what they're using AI for and start to ask whether AI is changing the set of tasks that people do, changing the way in which they do those tasks. So I'm excited about that type of question.
What was surprising about your results?
I think one of the more surprising things was how different or how important this user goal AI action distinction felt to us in terms of being able to isolate what the effect of AI is on work activities. Another thing I was surprised about was how strong the correlation was between thumbs feedback and the completion classifier. I had my doubts about the completion classifier and whether it was picking up real signal, so that was encouraging. Those were the two most surprising things to me. Yes.
How did you measure completion of the task? Because I know like sometimes agents can say, hey, I have completed your task successfully. Was that like a signal into completion?
Right, so our completion classifier got as input the entire conversation text and was asked to describe what the user was doing and then just do an LLM judgment of did the AI in this conversation complete the task of the user, which is one of the reasons why I was somewhat skeptical that this would work, but it appeared to get some real signal.
Well, thank you very much, Kiran.